Okay, my friends, this is 6.4, and we're going to talk about type checking. I don't know, 8 slides, something like that. Um, this this won't be too long. I think there's some key ideas that I want you to make sure you come away from this thing with. Um, so first of all, you've got to understand the notion of static type checking and dynamic type checking. I think it's really a key idea, a key concept. Um, So the fundamental definition of a static type check is that I've got to do that before I run it, right? Running, I'm dynamic. Before I run it, that's what static means. And so I've got to know it when I'm compiling it. And if I see that we're not consistent with the static types, then, I'm going to throw a compile error, right? 1 plus ABC, things like that, right? Things that don't make sense. And I think it's really true that most modern languages are at least, uh, you know, in large measure statically typed. That doesn't mean there aren't other kinds of checks that have to do with dynamic typing, right? That are just simply things that we do while we're running, right? Um, and there are other languages that are interpreted where the things aren't compiled at all, and that there's a lot of things you don't see until you're going, right? So that are part of modern languages, right? But for the most part, you're going to see static typing as a pretty standard thing. In dynamic typing, in the extreme case, the programs aren't type checked before they're run, and and then they're typically dynamically type checked. It's almost never the case that there's like no checking at all. Um, you know, in other words, and what it really means for the most part is I'm trying to perform an operation and I don't know what it means. That the operations, because there's always underneath, there's kind of been a theme as we've gone through these relative to types, there's always an underlying representation, right? I've got to perform these concepts, these operations, and these things down in the hardware somewhere along the line, right? So I've got to have some in underlying representation that I can look at. And so if I'm going to add two strings and I'm overloading the plus sign with a concatenation, well, I got to know that, and then I've got to have that thing overloaded, and then I've got to know in the moment that it's okay, because I have a version of the plus operator when the types happen to be strings, right? Or when they're reals or when they're doubles or whatever, right? And that's typically how we do it, is by overloading these operators so they can be anything. And it's really a form of polymorphism. They can be whatever they want in the moment. But, ultimately it comes down to I'm trying to perform operations, and do I know what to do with that? And if I don't do that, like if I didn't have an overloaded plus sign for concatenation of two strings, and I just got two strings and I didn't do type checking, and I just treated them like arrays of numbers, and then I'm going to add them. What do I do? Do I just add the values of every? Do I add you know A to capital Z? I mean, do I add those two together? Yeah. In other words, it has at least something to do with trying to meet expectations. It's got to be a reasonable expectation for what somebody would want me to do with that. If I can have a plus sign and two strings, I probably want to go, that looks like concatenation to me, and that's kind of what I'd expect. But I can't just go, oh no, that's an arithmetic operation. I'll just add my first name and my last name mathematically. It won't make any sense at all, and it would be kind of stupid, right? You don't want to optimize a language to an obscure, bizarre case for the one guy in the world who wants to add his first name to his last name mathematically. That makes sense. So again, there's a certain, even, in this slide, it kind of goes, there's no type checking before being run. And that does happen. That really does happen where there's no type checking at all. And pretty sure JavaScript tends to be like that, and there's some others. But the more common case is that there's actually more of a hybrid, that there's a certain amount of static checking that requires a compiler, and then there's a certain amount of dynamic checking that way, because just certain things, evolve or change or whatever, on the fly. I mentioned in one of the earlier podcasts about how that I could do something like In some languages, depending upon how you set it up, maybe you can, you start to overrun the size of an array, and could be a compiler warning, could be a compiler error, or it could let me go, but then in real time, if I blow past the end of my array and start doing stuff, maybe at runtime I could figure that out, right? And these are just examples of, if I've got a name declared to be an array of 80 characters, well, I've defined my own type, right? I built a constructed type out of, saying it's an 80 character string. And well, that's my type. I created this thing called name. And but there's, if I said there were 80 characters, there's a maximum number that makes sense, even though the size of my index can be big enough to blow past it. Well, what's my dynamic system going to do about that, and how strongly is it going to warn me so that I don't, I can just think of so many times as a C programmer, in the classic days where I just learned the hard way, about how sharp that knife was, and just, accidentally cut myself so many times. And then you learn the ropes and you don't do that anymore, right? But anyway, that's kind of the idea. Typically, it's kind of a hybrid. Here's an example of Lisp, and the truth is I got to go dust off my Lisp. I haven't, I haven't programmed in Lisp in a long, long time. But, here's an example, right? The define defines a function. I'm going to call it f. It's going to take a and b as sort of whatever you want to call that. It's a tuple, or it's a parameter list, or whatever you want to view it. And then that kind of stack-based approach, right, where I'm going to give you the operator and I'm going to give you the operands. So it's a plus b. In Lisp, if a or b is not a number, it won't work. And a function, a call like f nil nil, isn't caught at compile time, but it is caught at runtime, right? And that's an example of dynamic typing in Lisp. So even though, so if we're in a position, imagine the extreme case where dynamic typing, doesn't actually double check all the types or identify all the types or things at compile time. When you're doing dynamic typing, you're still using types, okay? And what's actually happening is you're storing the types along with the values in memory. You've got to allocate a space, right? So I've got a variable, or I've got whatever, and I declare it to be of a certain type, and I identify the information in memory that goes with that value, so that as I'm doing certain operations, I can check. It's really like meta information if you think about it. I can check the meta information about a variable name, or about a variable before I go pull its value, and then I can say, okay, this has to be a Boolean. How do I treat Booleans? Or this has to be whatever, and then I can look in real time, and that's got to be built into the code that I compile in, to run, right? So I think you get the idea on that one. So, and again, I kind of said this, right? The static and dynamic. The truth is that it's most common to have some combination, right? And really, this is kind of what I've already said. And we're going to talk more about that with object-oriented languages when we get to chapter 13. Let me see. And then I mentioned this as well. Dynamically typed languages often use static typing, right? And Lisp again is an example of a dynamically typed language that do use some static typing. We do that in ML as well, right? Where we sometimes have to do things, to tell somebody something that it's a real, because it's just not going to work if we try to do, you're going to try to do a mod function, or you're going to try to do a division function or things like that. The types don't line up, where it wants to, kind of infer before it's actually using it. So some languages, like Java, like Modula 3, believe it or not, I actually had some experience with Modula 3. It was sort of like an extension of Pascal, actually, and I believe it was kind of like an object-oriented Pascal. But this is talking about the ability for the language to provide keywords and operators and things to the programmer, so that the programmer can do some checking of types, right? So in Java, you've got this instance of operator, right? And I can test the object type, and I can do some of those kinds of things myself while I'm, in the code itself, right? And once again, for that to run and to work, I've got to have information present at runtime, you know, even when it's primarily statically typed. And this is the last slide for this section for 6.4. But anyway, the reason we do it, right? You know, the reason we do type checking is you really need to understand this. Okay, this is the kind of stuff that I'm going to do something on the midterm. But the reason is more than anything about operations, right? And remember that operations most often are done in kind of an overloaded fashion where, you know, it looks like I've got, you know, I can do pluses all over the place and multiple, you know, whatever other operations all over the place. But the truth is there's like, you know, there's like 10 of them, you know, and they're different, you know, there's a different plus for integers plus integers or reals plus reals or integers plus reals and, you know, different combinations that I'm going to do different things because the language is going to give me that, you know. When there is, you know, so thorough that there are guarantees built in on a lot of them, like ML and Java, then we say that that's strongly typed, okay? And then when you don't have that, like C, then that's weakly typed, okay? And it just means that you got all kinds of flexibility, and I've told a few war stories already, ton of flexibility, and a ton of like deadly gunpowder that's going to just blow up in your face. I have been there, I have done it, but man, some cool stuff when it's time to, you know, kind of go quick, you know, go hard, go fast, get some stuff done. Anyway, but this is really the punchline. I want you to understand that about this value of typing and why that's so critical. It really has to do with just making sure that the stuff you're doing makes sense. If you don't do that, you get a bunch of stuff going on that just doesn't make any sense. You got to make sure that you're doing things that are causing whatever you're doing to make sense. Okay, that's the end of 6.4, and what's coming up next, and that will be the last podcast for the lectures on chapter 6, is going to be this type equivalent stuff, and that's the next and last one, which will be 6.5.